All right, we're going to be working with some examples for Pythagorean Theorem. Again, you have a formula that's associated with this. That's the two legs. The sum of the square of the two legs is equal to the square of the hypotenuse. The hypotenuse is the side opposite the right angle. So first we'll look at an example where, now a lot of this isn't drawn to scale, where you're solving for a hypotenuse. I can just call it a hypot. This way it gets it going quicker. This could be, given as an x, but we know it as a c. And basically what's happening is you're saying 4 squared, the sum of the square of your legs, so 4 squared plus 6 squared is equal to c squared. In this they gave you x. Now what you do is you square, take the sum. Now to solve for x, if it's squared, you're just simply taking a square root of each number. Now there's two ways to look at this. One is to simply just take the square root of 52, second square root, that's your symbol there, 52, and you get a 7.2. So x could equal 7.2 here, but in some ways they ask you to answer in radical form. So what you need to do is simplify with a factor tree down to 4 and 13. Here you have a prime number, here you have a perfect square of 4, so you could say the result of this is 2 square root of 13. Now a key piece to this is if I put in 2 square root of 13 into my calculator, it's the same result, 7.2. And that's what you'll start to realize. Now another question or type of problem you might have to handle is one where they give you a hypotenuse and a leg, but what's missing is the leg, not the hypotenuse. This is a little different. In this case, you're actually solving for the leg, not the hypotenuse. Remember, the hypotenuse is the side opposite the right angle. So your formula is set up a little different. This could be considered A or B, meaning A or B being one of your legs. So you have an x squared plus a 9 squared equals a 15 squared. Here you have x squared plus 81 is equal to 225. And what you want to do actually in this case, here we added these two together, but in this case you're trying to get x by itself, so you're actually gonna subtract. And you get x squared is equal to, I think that's 144. It is. And then x is equal to 12. Now this is one of those triangles that we call a Pythagorean Triple because it actually has two sides that are whole numbers, the 9 and 12, equal to another whole number, 15. Meaning 9 squared, 81, plus 12 squared, 144 is equal to 225, which is 15 squared here. And this would be your leg here, not your hypotenuse. So in this one here, we're solving for a leg. I want to show you a couple calculator tricks while you're working if you have problems simplifying radicals. So let's look at a triangle with a 4 and an 8. And in this one, again, we're solving for hypotenuse. Let's call it C. That's a terrible line. Let's see if I can fix that up a little bit. Now, that's not really a triangle there. It's more like a half of a grilled cheese sandwich. Well, let's just 4 square. Let's assume that's a straight line. It's a square. 16 plus 64, and I'm getting 80. Sum of the two squares, I'm getting 80 here. Now, a couple things I could do. I can take the square root of 80 on my calculator here, okay, and get a result like this. I could have also, instead of doing this work here, I could have said second square root and actually put in the 4 squared plus the 8 squared, okay, and I could have solved for the 8.9 there without doing the 16 plus 84. Now let's say I were to simplify this into an 8 and a 10, an 8 and a 10, a 4 and a 2. Again, 4 times 2 is 8, a 2 and a 5. Okay, and I recognize, okay, I have a perfect square. I have 2 square roots that repeated themselves, and I have the square root of 5 here. So actually, square root of 4 is 2. The 2 square roots that repeat themselves are also 2, and then I'm left with a prime number, square root of 5. So my answer here is also 4 square root of 5. So let's say you have a problem simplifying this, and you're in a multiple choice question. What I would have simply done is, okay, I would have taken my square root of 80, and then I would have looked at some answer choices, and I would have just ran through my answer choices until I found a match of the 8.9. And let's say one of the answer choices was 2 square root of 5. And I put that 4.2, okay, 4.4, that's not a match. That's one way to get this equal to the 8.9 that you had, and just if you're working with multiple choice answers and having a problem simplifying radicals. Here's a fun problem you might be presented with, in which where you have 2 triangles, and they're asking for this hypotenuse here. So there's a couple things going on here. One, you have a right triangle. If this is 90, this here is also 90. Here you have a hypotenuse and a leg. What we're solving for here, we actually want to solve for this, because if you have 2 sides, in order to use Pythagorean Theorem, you need to have 2 sides of a triangle. In this triangle here, we only have 1 side. So what you're looking at is, okay, how can I get this second side here? Well, let's use this 10-8 triangle. Now I know from my Pythagorean triples that this side is actually a 6. Okay? One way I could just quickly get that is I could say second square root 10 squared. I know I'm solving for a leg, so I know I'm subtracting minus 8 squared, and I could get a 6. Now basically what that did is it took the 100 minus the 64 and gave me a 36, square root of 36, 6. Now what I have here is I have 2 sides of a triangle, but in this case a little different. I'm solving for hypotenuse. Now what I could have done, let's say if I'm just looking for decimal form, second square root 6 squared plus 3 squared, and I could get an answer of 6.7. So basically what I did was 6 squared plus 3 squared equals x squared. I just took the square root of this, and that gave me 6.7. But let's say it was 36 plus 9, which gives me a 45. And I had to simplify this as a radical. Okay, that's a 3 and a 15. That's a 3 and a 5. The square root of 3 radicals repeat. So remember, if they repeat, that's basically square root of 3 times square root of 3, which is square root of 9, which is 3 square root of 5. And what you saw is in our first triangle, we solved for a leg, and then in the second one, we solved for hypotenuse. And that's how you can use 2 triangles to solve for one.